First of all, there are 5 elements. We need to swap 4 elements. We need to sort the 4 elements. The automatically fifth element gets in the correct position. So now let us assume there are n elements. So how many times that loop gets repeated, how many elements that should be swapped? N minus 1. So that is the meaning of this statement. So if there are n elements, we need to swap n minus 1 elements. Then automatically the other element in the correct position. That is the meaning of this line. Repeat n minus 1 times and compare the adjacent elements if swap needed. Okay, I'll reduce the range of comparison after each iteration. So after iteration 1, so how many elements get swapped? And 4 out of 4, 3 elements get swapped. And now I'll go with an example, and before that, let's see what is the pseudocode actually. Okay, it is we know already the pseudocode is a kind of algorithm that anyway for pseudocode there is no compiler, there is no interpreter, the pseudocode will get executed, will not get going to execute it. This is the kind of algorithm. Now def bubble sort array, that we are passing one array, we are going to find out the length of the array for iterating. So length arr, it returns the length of the array. Now for I in range, how many times that loop gets repeated, how many elements that you need to swap initially? Let us assume there are 5. You need to swap, you need to do the iterations 4, n minus 1, 5 minus 1, it is 4 actually. Now when it is true, initially the range function will start from 0 to n minus 1, means 0 to 4. Then the control will be entered into j loop, I loop for number of iterations, j loop for swapping the numbers. Okay, there are 2 for loops here. One for loop is for outer for loop is for number of iterations, and inner for loop for swapping the two numbers. When I initially 0, 0 to n minus 1 means 4. Now it is true, control will be entered into j loop. Okay, j in range, from j where to start? From initial number. Okay, n minus I minus 1. What is n? The total number of elements. What is I initially? It is 0. 0 minus 1. So 4 iterations for the first pass. We need to pass, we need to iterate, we need to swap 4 numbers. So that n minus I minus 1. Then if the first element is greater than the next element, array of j greater than array of j plus 1 means the first element, if the first element is greater than the second element, then we are going to swap. Simple. If it is not true, no need to swap it. Okay, go to the next iteration. So now here one element got in the correct position, then control will go to I becomes 1, so 1 to 4. So that is for second pass. This is second pass. Now control will be entered into j loop, again start comparison from the first element. This loop gets repeated until how many pass, how many iterations? N minus 1 iterations, that many times, because for each iteration one element gets in the correct position. Okay, this is all about the time complexity. Best case, if it is already sorted, we need O of n iterations, and if it is worst case, in reverse order, we need to time complexity, the number of iterations are n square, and average case also n square. I'll go with one example. You can see here, sort 5 3, the same example, 5 3 4 8 2. Now we need to keep in order by using bubble sort. Now pass 1, the outer for loop I, when pass 1 means I may be started with 1 or 0, whatever it is, that is according to our wish. Okay, the pass 1 for the first iteration, 5 will be compared with 3. Now swapping is required because 5 is greater than 3, so swapping is required. Now swapping is done. Next, 5 with 8, 5 and 8 will be compared, so no swapping is required, no swap, right? 5 with 8 means next, no swapping because the first element is not greater than the next, so that no swapping as it is. Next, third iteration, you can see 8 with 4. 8 versus 4. Now 8 is greater than the next element, so that swapping is required. 8 and 4 will be swapped. Next, 8 and 2. Comparison, 8 and 2. So 8 is greater than the next element, so swapping is required. So now 8 will be moved to next and 2 will be before. Now you can see, you can observe, this is the list is not sorted completely. Only the one element gets in the correct position. Okay, and remaining you can observe 3, 5, 4, 2 is not in the order. Okay, but 8 in the correct position anyway. You can cross verify. Out of these 5 elements, the 8 element in the correct position. Okay, when pass 1, this is for outer for loop. Pass 1, pass 2, pass 3 is for outer for loop. How many passes are required? How many iterations are required? N minus 1. Why n minus 1? We have 5 elements. Out of 5, if you swap 4 elements, automatically the fifth one in the correct position. So that how many passes are required? N minus 1. Now only one pass is done. For pass 1, only 8 in the correct position, the last element in the correct position. Okay, now you can see the here largest element 8 is now at the last position. That is means that is now pass 2. Pass 2 again start comparison from first. 3 will be 5, so no swapping is required, right? Next, so as it is, next 4 will be with 5, 4 will be 5, so no swapping is, sorry, 5 will be 5 with 4, now swapping is required. Okay, now I am talking about the second iteration. 3 with 5 and no swapping. 5 with 4, swapping is required. So now 4 will be shifted here and 5 will be shifted here. Now 4, 5, 2, 8 and remaining will be correct, same as it is. Next, 5 will be compared with, here there is a small mistake, you can see. 5 will be with 4 anyway. Now it is sorted, right, no wrong. Next, 5 will be compared with 2. Okay, so now 5 is greater than the 2, so swapping is required. So 2 will be shifted here and 5 will be shifted here. Now again, this is the last element anyway, that is already sorted. Now you can observe 5, the second largest element, is in the correct location or correct position when the pass 2 means, so second iteration when I is equivalent to second iteration, either it may be 2 or you can start with 1 or 2. Now when the pass 2, the second largest element in the correct position, but you can observe the remaining 3 elements are not in the order. Now let's go with the next iteration, because how many iterations are required? N minus 1. So 5 minus 1, 4 passes we need to do. Now coming to this list, 3, 4, 2, 5, 8. Now 3 will be compared with 4. So is it swapping is required? No, it is less than the next element, so that no need to swap. Now 4 will be compared with 2. Now swapping is required because before that the less than elements and later the greater than elements must be there. Now 2 and 5 will be compared. 4 is greater than, means first element is greater than the next element. So swapping is required. Swapping is done here. Now again 4 will be compared with 5 automatically by the interpreter. I didn't mention here. But anyway, it is in the order, and 5 will be compared with 8. Okay, and no need to swap, and everything is in the order within the iteration 3. Okay, now you can observe the third element gets in the correct position. Okay, you can observe the 3 and 2, the remaining first 2 elements are not in the position. Okay, now for the 3 passes, for the 3 iteration, 3 elements got in the correct position. So 4 is in the place, correct place. Now coming to the pass 4, now only the first 2 elements need to be sorted. Anyway, I mean, computer will do all the iterations, but for us, we are going to swap with 2 and 3. Sorry, what is the list that we have written? Actually 3, 2, 4, 5, 8. 3 and 2 will be compared. So 3 and 2 will be compared. 3 is greater than the next element, so swapping is required. Now after swapping, this is the list or array. So 2, 3, 4, 5, 8. Again, the interpreter will compare 3 and 4. Now no need to swap, and 4 with 5, no need to swap. 5 with 8, no need to swap. Okay, now you can observe at the fourth pass, all the elements get in the correct position. Okay, this is what exactly you can observe clearly. How many iterations? 4 iterations.